Okay, what's going on, everybody? Hope you're hanging in there at home. What I'm going to do today in this video is I'm going to kind of give you a little information about this molecule shapes lab. Kind of maybe answer any questions you have before you get started. Anyway, as I pointed out in the assignment itself, what you're probably going to want to do is try and find a way to print this out, because there's a lot of drawing and a lot of sketching built in on this. You do have the option, of course, of taking pictures of sketches you make just on your own paper and then inserting those as image files into the Google Doc, but it's probably going to save you a lot of time, either just come by the school or have somebody come by the school and pick up the paper on your behalf and get it to you, or print one out yourself. Anyway, the point of this is to further acquaint you with some things about the three-dimensional shapes of molecules. We have a lab that we do in class if you're here, and I'm kind of test piloting this one out for those of you who aren't able to join us in person. So the first thing that we want to take a look at is here in the introduction. It gives you information about electronegativity, about electrons wanting to have a set of 8 valence electrons, or an octet of electrons, in order to become stable, and that's why they form bonds. Jumping right into the actual action here, in this part 1, they want us to build some generic molecules. So in the sim itself, you've got 2 tabs. You've got a real molecules tab and you have a model tab. You're going to start with this model tab here. And we're going to build each one according to what they tell us to build here. So starting off, we're going to draw the molecule. We're going to write down its molecular geometry name in the box. The molecular geometry they'll give us here in the name. Label the bond angle. I'll show you how to find that. And then also we're going to check on the central atom and see if it is quote-unquote octet satisfied, meaning does it have those 8 valence electrons, either the ones it brought by itself or the ones that it's sharing. So the first one it wants us to make right here is one called AC2. And if you look in the key, A is the central purple atom, C is a double bonded white atom. So what I'm going to do is I'm going to get rid of these single bonded atoms that are here in the sim by clicking the X. And I'm going to add 2 of these double bonded white atoms like that. Now we can spin this around, we can kind of take a look at it, and you'll note just by looking at it, it appears to be linear. So what I'm going to do is I'm going to come to my box, I'm going to draw more or less exactly what I see there. I just happen to have a purple pen here with me, so I'll be able to make myself a purple molecule. And add in a couple of white ones to either side, and then put in the bonds as shown in the window there. Okay, that's more or less what they're showing me there. Underneath there, it wants me to put in molecular geometry and whether it satisfies the octet rule. Well, molecular geometry, I'm willing to bet that this is linear. And sure enough, when I click the checkbox, that's what it tells me. So I'm going to write linear here in the blank, or in the shape of a line. Now, as far as a bond angle, if I click over here and click Show Bond Angles, because it's a line, that's a bond angle of 180 degrees. And you can kind of spin the molecule and see that. So I'm going to come into my drawing, and I'm going to label that. Degrees. As far as octet, each one of these represents a pair of electrons. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So for this guy right here, yes, he is satisfied. So I'm going to just put a check mark. Come over to the one right next to it. Is ABE3. So looking at my key, let me get rid of some of these things here. Now I'm going to get rid of this and get rid of the bond angle just so I don't spoil it for myself. A again is my purple atom. B is a single bonded white atom. So I'll put him in. E is electron pairs that are not bonded, or otherwise it wants me to put in some lone pairs. So 3 of those, so I'll click this 3 times. Notice how each time I do it, it moves the other things that are in that molecule around. Okay, so I put in my third one. I'll take a look there. Depending on how I have it spun, I can either point it toward myself or kind of point it to the side there. I think putting it like that's going to be the easiest way to draw it. So on my paper, I'm going to start with my central purple atom. I'm going to put in my bond, my white atom up here. And then for my lone pairs, I'm going to kind of put them, let's try using some pencil. I'm going to kind of put like a, more like a grayish cloud. Kind of shade that in a little bit. Got one coming up toward me there, looks like. Shade that in. And another one coming over here. I'll shade that in. Okay. Molecule geometry. Going with my axe method, if that's my central atom, it's got 4 things coming up. So steric number 4, but only 1 branch. So 1 branch with 3 lone pairs of electrons. I'm not even sure that's on our chart. But it looks to me like it's almost tetrahedral. So let's click molecular geometry. See, now they're saying that's linear. Oh, I know why. Check it out. Because if I'm just looking at the geometry of the 2 atoms involved there, see if I hide my lone pairs, then it is just linear. There's just 2 atoms there. That makes sense. So I'm going to come over here, and again I'm going to record linear. My molecular geometry. And as far as an octet, let's count electrons. We've got 2, 4, 6, and then 2 more that are in that bond, so that's 8. So I'd say yes, that is a stable octet. Let's take a look at some of the other pages. Let me do a little bit of skipping ahead and see if I can spot any trouble spots for you before we get there. Page 2 looks like it's just going to have you doing more of the same. Oh, let's come back to this real quick, something I forgot to mention. Almost forgot to look at bond angle. I want to say, yeah, see when I click bond angle, nothing appears. The reason for that is because I don't have at least 3 points to make a measurable angle with. Okay, it's just 2 points, and so there's not another line segment or not another bond in there that I can compare against. So there is no bond angle on this one. I just want to be sure that I wasn't forgetting that. So maybe I'll come back to my paper and I'll just make a little note right here, no bond angle. Now let's take a look. At the 3rd page, we're given part 2, real molecules. So it wants us to click on the real molecules tab, use the pull down menu, select the molecules below, and fill in this chart. Okay. Well, let's start with one we've seen before. Let's start with H2O. So let me bring my lab back up. I'm going to click real molecules. It's actually at the bottom, not at the top. And hey, sure enough, H2O is the first one that they pull up. So as far as generic structure, what they want me to do is they want me to match this up to one that I've seen before. And since I haven't drawn one that looks like this, I think I'm going to look at some of the other options they've got here and see if I can find one that matches something we've already seen. Not you. Nope. Things get really, really complicated. No, not you. Okay, so let's take a look at the model here. The model, we've got a purple with 2 singles and 2 lone pairs. So going back to my paper, looking at page 2, I'm going to see if I can find the one that would give me that. So that would be A with 2 B's and 2 E's. So we're looking for A, B2, E2. I'm willing to bet that's that guy right there. And if you have worked through this instead of skipping around, I'm sure you'd look at that and say, hey, absolutely, Mr. King. That's absolutely right. You're a genius. It is A, B2, E2. So when I come over here to generic formula, wants generic bond angles from part 1. Okay, fine. I guess I'll go back and we'll take a look at this for part 1, and let's get rid of some of these. So AB2E2 means I'm going to have 2 single bonds. I'm going to have 2 lone pairs. Okay, so there it is. You can see it looks a little bit like that water molecule did. Now it wants to know generic bond angles from part 1. So let's take a look at our bond angles here. Got an angle of 109.5 degrees. So I'll put that in as my generic bond angle. Now when I go over to true bond angles, let's go to real. So there's my water molecule. Now if it's correct, it should be 109.5. So when I click show bond angles, oh, it's actually 104.5. So it's a little bit different than what the model would suggest we would find. And that probably has a lot to do with the electronegativity of some of these different atoms that are involved in this molecule. So I'll put that in as my true bond angle up here, 104.5 degrees. So the point of that is just to show you that the models are not always going to line up one-to-one with what you actually find. And sure enough, you can double check that. When I click model on this tab here in the real molecules thing, 109.5 is, if I stop my smoke maybe, 109.5 is the bond angle that they expect me to find versus what's really there in the water molecule. So you'll do something similar on the rest of these that are in this table on part 2. Part 3, we're going a little bit deeper. We're going to go with the octet rule breakers. So while still in the real molecules tab, select the following molecules, draw each molecule, name the geometry, and write how many electrons are on the central atom. So let's look at SO2 from our drop-down menu. Okay, sulfur dioxide. Now that's interesting. Now if I was to call that molecule shape, it's all in a plane, but it makes a triangle, so that would be trigonal planar. Let's start by drawing this, and oh, you know what? I think I've got some yellow highlighters here, so I'm going to draw that central atom there. I know it's not the same shade of yellow, but I'll shade it kind of yellowish. Looks like it's double bonded to 2 other atoms out here. I'll kind of color code them. Not quite red. It's red if you squint. It's double bonded. And then again, I'm going to put in that lone pair of electrons up here, kind of in this cloud. It's like a robot ghost or something. So let's put in the molecular geometry. The molecular geometry, it looks to me like a trigonal plane. Oh, that's right, because that, if I get rid of lone pairs, yeah, the molecule itself is just bent. So molecular geometry, I keep falling for that. Molecular geometry on this is just going to be bent. Now, My bond angle here is 119.0, and I'm going to write that in down here, 119.0 degrees. What does my model say it should be? Model says it should be 120, so that's pretty close. But now let's look at how many electrons are here. So I've got 2, 4, 6, 8, 10. I've got 10 valence electrons. That is a rule breaker. And the thing is, when we talk about atoms needing a stable set of 8, that is for them to be at their most stable. But there are situations where they can be forced into having more than the usual 8. And the chemistry behind that's a little more complicated than what we're going to be covering in Chem 1. But it is kind of a fun exercise to come through and just kind of play around with it here in the simulation and get things that we wouldn't even be able to get in class building with our little wooden balls and sticks. So you're going to do the same for the other molecules here. Over on page 4, there's a couple more. And then we get into some post-lab questions. So it asks, what does VESPER stand for? If you go back and look at the notes or watch the video that I recorded a few days ago, or actually just yesterday, the notes talk about that. I'm not going to really get too deep into these questions. I think you should be able, between what you find in the notes and what you are able to play around with and discover in the model, you should be able to answer most of the rest of these. Now this down here, who are the 2 most electronegative elements on the periodic table? That I know for a fact. I gave you an image that has the table of electronegativities. So you should be able to get into Google Classroom and pull those up. I'll give you a hint. One of them got locked up by her older sisters, so she wouldn't be the most attractive element at the disco. If you don't know what I'm talking about, then yeah, how did you find this channel? Anyway, good luck with this, and if you have any questions, feel free to leave them for me on Google Classroom or shoot me an email. Good luck.